This is Jack Jackson. We're going to be looking at congruent triangles. This is part of my sketch Triangles Ultimate. And so, by definition, we say a triangle ABC is congruent to triangle DEF. IFF is short for if and only if. All 6 of the following corresponding parts of the two triangles are congruent. BC is congruent to EF. Notice I've marked that here with it's blue, where this one down here is blue, and it also has a single mark here and here to indicate that those are congruent. Likewise, the two green sides, AC and DF, are congruent, and then also the two red ones, AB and DE. But notice that the order you write this is important. A has to correspond to D, B corresponds to E, and C corresponds to F. And of course those angles must be congruent as well. Angle A must be congruent to angle D, the two blue angles, here and here. The two green angles, B, the one in the middle here, the one in the middle here, B and E. That's 2 marks here in green and here, and 3 marks here in red for this one and this one. Angle C and angle F must also be congruent, meaning they have the same measure. So it takes all 6 of those, and of course if we do that, then we should be able to take one of these, and by moving it around a little bit, we should be able to place it directly on top of one of the other one, and they should match up perfectly. We might have to reflect it. We might have to translate it, rotate it. In this case, we translated and rotated it. In some cases, we might also have to flip it over and reflect it. But if we can do any combination of those things and one lands right on top of the other, in general, we say the two figures are congruent. So here we have the measurements, and the yellow points A, C, and B control the triangles. So the sketch is designed in such a way I can get any possible triangle here that I want, but whenever I do, we get this one down here stays the same, so I can manipulate triangle ABC, and triangle DEF is changed accordingly. So that's what we mean by congruent triangles. So all the corresponding parts, all the 6 corresponding pairs of parts must be congruent. So the 3 sides must equal each other in measure, and the 3 angles must equal each other in measure. When I'm saying equal each other, not within a triangle, but from one to the corresponding part of the next. Now, one major question that we want to ask is this. Even though it requires all 6 corresponding parts to be congruent, if we're given less information, is that enough to completely determine that the triangles are congruent? What if we only have 5 of the pieces matching? What if we only have 4? What if we only have 3, 2, or 1? Well, it turns out that if you've got 4 parts, that's always enough. 4, 5, or 6, of course, that's always enough to make them congruent, and 2's never enough. But the question is, what about 3? So we're going to investigate that in a little more detail and see what happens in those cases. So there's 6 possible, 6 possible cases. We can know a side is congruent and an angle and a side. Like we can know the blue sides, the green angles, and the red sides. We might know that is congruent. If they are, is that enough to say that the rest of the triangle has to be congruent? Or what if we know all the sides? What if we know the 2 blue sides, the 2 green sides, and the 2 red sides are congruent in pairs? Is that enough to conclude that the angles are congruent? Or what if we know 2 angles and a side? Either angle side angle is where you knew 2 angles, like perhaps the red angle here and the green one here and here, and we know the side in between, angle, side, angle, or you can read it this way, angle, side, angle. What if we know that? Is that enough to conclude that the other angle and the other sides are congruent? Or what if it's angle, angle, side? That's also 2 angles and a side, but it's in a different order. It's like the blue angle, the green angle, and then the blue side. Angle, angle, side. Or it might go this way, angle, then angle, and then side. Okay? Or what if we know all three angles? Is that enough to get the sides congruent? Or what if we know side, side, or angle? That could also be written as ASS. Angle, side, side, or read it the other way, side, side, angle. So notice when we're reading these, they go right in order. So this one, side, side, angle, says the first side is opposite the angle. So if we know angle, we know the opposite side, and then we also know one of the other sides. Side, side, angle, or side, side, angle. We know those match up. Is that enough to completely say that the other parts are congruent? Okay. The other one, angle, angle, side, that has one that's opposite. The A, first A and the S. So angle, angle, and then a side, and the side is opposite that first angle there. So we can look at these in sort of this question in sort of two different ways, two different questions. If we're given specific measures for given condition, like we're given a measurement of a side, an angle, and a side in that order, specific numbers for the measurements, how many different triangles can we make? First of all, does there even exist a triangle with those measurements? And if there is a triangle, do all the triangles have to be the same measure, or can we make two different ones, or maybe three, or maybe infinitely many? What conditions, which ones of these make it where there's only one thing happen? Okay, so that's where we're given specific measures. Another way to do it is if we're giving, the other way to look at this question is if we're given two triangles, like these two triangles, and we know certain pairs of information match up, okay, then is that enough to conclude that the rest of it has to match up with the equal measures so that the two triangles are congruent? So, in this sketch, we have tabbed pages for each of these. Most of these have usually 3 pages. There's the first one, like SSS, we'll look at that condition. It investigates it with sliders. Then SSS2 investigates it by putting in specific numbers. And then if there's a proof or something or more information page, that follows after that. So what we're going to take part of our time in our class projects and in investigation on this sketch for the next couple of tabs here and the next part of our course here for just a little while is going to be examining each of these conditions: side, angle, side, 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 angle, side, angle, 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 side, angle, 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 and side, side, angle, and decide which of those forces us to have congruent triangles.